Work boots are made from cowhide, which has undergone mineral tanning and finishing tanning. A waterproofing treatment completes the preparation. Let's follow the process. This machine is a shaver. It evens up the hide and opens its pores before it receives other appropriate treatments. They treat the hides in this retanning drum. Water, coloring products, and retanning products are at a temperature varying between 32 and 60 degrees centigrade. Hides are then removed from the retanning drum. The leather will then be vacuum dried for 2 minutes at a temperature of 70 degrees. Then the hide will be hung for 24 to 48 hours. Here the hide is stretched on a vacuum drying plate. It's evened out to get rid of any creases. A hide measures almost 2 square meters, and they'll need about 0.4 square meters of leather to make a boot. They begin cutting the boot parts. This punch, with the help of a press, cuts the different pieces of leather. They also cut brown fabric pieces, the interior lining of the boot, made from a foam base and woven polyester fibers. This paring machine thins the edges before they're sewn. During the cutting, each piece of leather is identified by its size. They now begin assembly of the boot. The 2 sides of the boot are sewn together on this machine. Now the front part of the boot is assembled. Excess leather is progressively cut away. The eyelets, made of steel, brass, or aluminum, are then positioned. Here they attach a foot mount on a form with tiny nails called tacks. The last is placed in the boot to facilitate the assembly of the front part. This carding machine removes any unevenness at the level of the lining before proceeding to the next step. They now install the tempered steel toe cap. The lining is pulled, they insert the cap and fix it well in place. The leather is folded beneath the boot, the bottom secured with a tack, and the sides fastened with hot glue on this seat-inside lasting machine. The boot front is now finished. We get a good view of the application of the hot glue. At this stage, they remove the last, installed at the beginning. It's no longer needed. Now the sole will be installed. The heel core is of pine. It's put onto the sole, which will soon be secured into place. Here they proceed with machining and welding of the rubber sole to the boot tip. It's called vulcanization, done at a temperature of 165 degrees, and the sole is solidly installed. This machine sands the edges of the sole to eliminate any vulcanization residue. They also apply a sealant. They now place an insole inside the boot. Here they install the laces and stitch on the labels. The boots now leave for the packaging area. Building a pair of boots required no less than 123 different fabrication steps, including packaging. Each pair needs 101 meters of nylon, cotton, and polyester threads, and close to a square meter of thick and rugged leather. Adhesive bandages are made of various materials, among which is the main support called ETS, a fabric which is elastic in only one direction. It's a fabric which will become the adhesive portion of the bandage. This 1,800-meter roll of fabric can make 1.8 million small bandages or 300,000 large bandages. A thin coating of glue is applied on one surface of the fabric. Then it's heated to 49 degrees centigrade in an oven to puff it up, creating holes in the glue coating. Then the fabric is newly rolled up into 300-meter lengths. Bandages are of different sizes. These blades cut the glued rolls into strips of varying widths. These rolls are taken away and stacked, ready for the next step, application of the little cushioned protective pads. The material used for the pads are shown here as a large roll of fabric, which will have to be cut. Here a machine cuts the fabric pads. These extremely sharp blades have to be sharpened every 6 months. The cushion fabric is separated into narrow strips, which will later be glued to the ETS fabric. The strips of cushion fabric are now ready to be applied to the bandages. This is the machine that fabricates the bandages. The roll of bandage components is unrolled. The machine assembles them, then cuts and individually wraps them. The bandages are wrapped one by one. This machine applies the unprinted white wrapping paper, which protects the bandages. And now they proceed to packaging. Packaging speed depends on the product, varying between 300 and 1,500 bandages a minute. This roller perforates holes which will allow the bandages to be easily separated from one another. Strips of bandages are then placed into boxes. Here we see other small bandages which are made in a different way. The cushion strip is positioned at the center of the ETS fabric strip. The cushioned pad isn't sterile at this stage. They will have to be sterilized right at the end of the fabrication process. Next step, applying 2 plastic paper protectors over the glue-covered ends of the bandage. This done, the bandage is drawn by suction with a robotic arm and placed between 2 wrapping papers. In slow motion, we see the wrapping action better. This machine is much faster than the eye. At full speed, it can wrap 300 bandages a minute. The bandages exit the machine perfectly wrapped. Certain types of bandages have to go through a sequential bandage machine to have aeration holes pierced in them. These holes allow air to circulate and thus help promote healing. These bandages are now ready. Sometimes they print instructions on bandage wrappers. This paper printing machine is used with bandage machines. 2 polymer plates receive ink from a series of rollers in order to reproduce the desired design. The bandages pass through at high speed. Before being packaged, the bandages are finally sterilized 10,000 at a time. Bandages are automatically counted here, placed in a chute, and fall into the packaging box. The large roll of ETS fabric seen at the beginning will have allowed them to make nearly 2 million bandages. Each year, this facility produces a staggering 4 billion bandages in 65 different models.